Hi guys, how are you? We're just going to have a look today at strong acids and doing a couple of simple calculations around strong acids. Okay, so the first thing to know about strong acids is what they are. So a strong acid dissociates completely in water. This is something we would have talked about in fifth year. Okay, so for example, in this HCl molecule, if you have this in a solution of water, all the HCl breaks apart. Every single molecule breaks apart into H plus ions and Cl minus ions. Okay, so that's what it does. And that's really useful in some ways because it means we know the concentration of the H plus ions, okay? If the concentration of HCl at the start is 0.1 mole per litre, the concentration of the H plus ions at the start is 0.1 molar litre. And that's really useful to us because when it comes to getting the pH, we know that we get the pH by getting minus log of the H plus concentration. So if the H plus concentration is the same as the acid concentration, that's really easy. We just get minus the log of 0.1 in that case, right? Things are a little bit more complicated for acids that are what are called diprotic. Okay, so this is a diprotic acid. Simply what that means is that there are two protons in the molecule. Can you see that? H2SO4, right? And what that means is that when that dissociates or breaks apart, so sulfuric acid is a strong acid. Again, all the molecules in solution break apart. So if you have a concentration of sulfuric acid of 0.1 mole per litre, well, then the concentration of hydrogen ions are going to be 0.2 mole per litre, twice that. Makes sense, doesn't it? Because the molar ratio here is 1 to 2. So in this case, if we want to get the pH of sulfuric acid, we're going to have to use minus the log of 0.2 to get our pH. Okay, so the acid the acid will be stronger. The corresponding concentration will be stronger if it's sulfuric acid. All right, now the easiest way to do these is really just to do a couple of examples. So I'm going to do a couple with you very, very quickly. Really easy ones, okay? Nothing too difficult here. This is just strong acids is what we're looking at today, okay? So the first one we're going to look at is from 2018, question 11. And it asks you for the pH of a 0.5 molar HCl solution, right? So what you're going to do is you're going to get minus the log of 0.5. That's really easy. Make sure you know where your log button is. That's it there. Putting it up to the camera so you can see it. It's just under the X button. Can you see that? See where it says log? There you go. Is it focusing? There you go. Log. See? There. Right. So it's minus the log of 0.5. Put that into your calculator and you should get 0.3. So that's quite a straightforward. That's kind of the easiest type of question you get asked, okay, where you just literally plonk in the numbers, but you do need to know where your log button is, right? Sometimes what they ask is, they ask a slightly more difficult question. 2017 question 9 is a little bit trickier. This is one where they've given you 3 pHs and 3 corresponding acids, okay? So the 3 pHs are 0.7, 1 and 2.37, and they say that these acids these pHs are the pHs of HCl, H2SO4, and a weak acid. Now, we know that the weak acid is 2.37 because it will have a pH that's higher. We don't need to worry about that. We're going to deal with weak acids later. For now, we're going to try and explain why the one of the acids is 0.7 and why the other one is 1, okay? We're told that they all have a concentration of 0.1 mole per litre. So basically what we're going to do is get the pH of a 0.1 molar HCl solution, sulfuric acid solution, and see if they match up with these two numbers. That's basically what we do. So that's easy enough to do. We're going to start with HCl. So we're going to get minus the log of 0.1. Okay, so when you do that, minus the log of 0.1, you put that into your calculator, you get 1, which is great because that's one of the numbers we were given. So we now know that the pH of HCl, of a 0.1 molar HCl solution is 1. Happy days. Right. Sulfuric acid, a little bit trickier because we're told that the concentration of sulfuric acid is 0.1 molar. So you need to remember that it's diprotic. So the concentration of the H plus ions for a 0.1 molar H2SO4 will be 0.1 times 2, which is 0.2. Okay, so in this case, for sulfuric acid, we're going to put in minus the log. Can you see that? Sorry, I'm crooked a bit, am I there? Minus the log of 0.2, which gives us 0.7, which matches up nicely with one of the concentrations that we got there. Is that okay? See what we've done? So again, the real question there is, do you understand the difference between mono and diprotic? Okay. One last question I want to do with you, which is 2016. And in 2016, they asked for the molarity of a H2SO4 solution, okay, where its pH is 2. Now, this is kind of backwards, okay? This is where they give you the pH and they want you to figure out the concentration of the ions and from that the molarity, okay? Now, this is really easy to do again. All you need to do here, basically what they're doing is they're telling you that minus the log of the H plus concentration is 2, because we know that the pH is there, and you're trying to find this, H+. And then you've got to remember that it's a diprotic acid, so that the concentration of the acid will be half the concentration of this, okay? But first of all, you've got to get the inverse log of that, okay? So inverse log, I'm sure you've done that in maths, is second function and log. So you put shift, log, and then -2, because remember you're bringing your 2 over there, okay? It looks like this. And when you put that into your calculator, you should get 0.01 if you've done it correctly, okay? So minus the log of the shift button, inverse log, -2, you get 0.01, okay? That's the concentration of the H+ ions, but then we know that the concentration of the acid is half that, isn't that right? Because it's diprotic. So we divide that by 2. So the concentration of sulfuric acid at the start is 0.005 molar, like that. Is that okay? So they're the sort of different formats that the questions about strong acids come in. There's rarely anything different from that. You need to either calculate the pH directly or work backwards and calculate the H+ ions and just try and remember whether it's monoprotic or diprotic. They often ask about that. All right. Hope that helps a bit. Best of luck. Bye-bye.